Good day to all. This is Dr. B. Yamini, Assistant Professor, Department of Networking and Communication, School of Computing, SRM Institute of Science and Technology, Katangotu. In this video session, we are going to see about Unit 1 topic called Specification of Tokens under Compiler Design subject. So, before letting into the specification of tokens, we must know what is a token. For understanding token, we must have an idea about lexeme, pattern, and then we'll go with token. Okay. So a lexeme is a sequence of characters in the source program that matches the pattern for a token. So a combination of alphabets or sequence of characters in the source program can be called as a lexeme. If it matches with the pattern, then it is called as a token. What is a pattern then? A pattern is nothing but a set of rules that a scanner follows to create a token. Say for example, in our programming language, we will have some set of productions and that is called as the regular expression. Every regular expression is the rule to be followed for identifying the token. Okay. So some sequence of characters are matching this regular expression rule is nothing but called as a token. So a lexeme is a sequence of character in the source program. This is going to match the pattern, that is the set of rules that forms the token. So again I repeat this topic like lexeme and pattern. A lexeme is a sequence of character in the source program that matches the pattern for identifying a token. Then what is a pattern? Pattern is a set of rules that the scanner follows to create a token. So we know that what is a scanner? Scanner is the lexical analyzer phase. So a pattern explains what can be a token. This is the rule to identify a token. So coming to token, a token is a pair consisting of a token name and optional attribute value. So it is going to be the combination of these two, that is the token name will be there and it has its attribute value, that is it's an optional one. So it is an abstract symbol that is a kind of lexical unit. Example, a keyword may be called as a token, which is nothing but what? A sequence of input characters. Say for example, if is a keyword, for is a keyword, int is a keyword in C language. So it is if, a sequence of input characters like I and F denoting an identifier called, and this set is called as a keyword. The token names are the input symbols that the parser processes. So this keyword or identifiers, whatever it is, that is going to be given as input to the parser after identifying it as a token by the lexical analyzer phase. Okay. So in programming languages, keywords are called as tokens, constants can be a token, identifiers can be a token, and strings can be a token. Numbers, operators and punctuation symbols are also called as a token. So specification of tokens. So far we have seen what is lexeme, what is pattern, and then what is a token. So token is nothing but the set of characters that matches the patterns. In simply if we say set of characters that matches the pattern is called as what? The tokens. Now what would be the specification of tokens? So there are a number of specification of tokens that we are going to see under this topic. So the regular expression is an important notation for specifying patterns. Yes, of course, because it is a set of grammar that has been identified as productions. That set of regular expressions is going to be an important notation for specifying the patterns. Yes, the rules, right? So formal notations of regular expressions are as follows. Under this we are going to see about formal notations. We are going to see 5 topics. First one is strings and languages. Second one is operations and languages. The third one is regular expressions, regular definitions, and the extensions of regular expressions. So coming to the first heading, strings and languages. So we have to know what is a language. So before going to a language, what would be the string? And before going to the string, what would be the alphabet, right? So alphabets are nothing but, say for example, English language if we consider. So it is going to have a number of alphabets, that is from 26 alphabets from A to Z, right? So it may be of capital letter or it may be of small letters. So this A to Z is finite set, which means that it is countable, which is 26 letters of alphabet from A to Z. So it is nothing but any finite set of symbols. A is a symbol, B is a symbol, C is a symbol, like that till Z is a symbol. So any finite set of symbols is going to be called as an alphabet. In digits, if we say it is like 0 to 9 will be considered as what? The alphabets, digits alphabets, okay. And if it is a binary alphabet, we will be having binary means 2. We know that it is 0 or 1. 0 and 1 are the set of binary alphabets. So string. And in English language itself, the combinations of characters is going to form a word. Word is a string over here. So it is also going to be a finite sequence, right? So string is any finite sequence of alphabets is called as a string. So it has its length. Every string has its length. If it is an alphabet, it is of only one symbol. If it is a string, it is going to be combinations of alphabets which has its own length, and is the total number of occurrences of the alphabet also. A string of 0 length, if we say that no alphabet is there, and a string will be called as a 0 length string, and it can be identified with an epsilon symbol, which is called as an empty string, okay. And next comes the continuation of strings and languages. In this, we are going to see about languages. So far we have seen about what is lexeme, what is pattern, what is token. Then we started with formal notations. In that first topic, we have seen about strings and languages. Under strings, we have seen about alphabets. What is an alphabet? What is a binary alphabet? What is a digit? And then we've continued with strings, and then we are going to continue with languages. So now all these strings, you know that alphabets together, there is combined alphabet or combination of characters is going to form the string. And from the string, there is this group of string is going to give you the language, right? Isn't it or not? So a language is considered as a finite set of string over some finite set of alphabets. So finite set of strings, that is also countable, and over finite set of alphabets. Yes, of course, from the alphabets only we got the string, and this finite set of strings are going to be in a particular language. So the computer languages are considered as finite sets. Mathematically, set operations can be performed on them. So what are all the mathematical set operations are? Set operations, we know that union, intersection, these are some of the set operations that can be performed on computer languages. So finite languages can be described by means of regular expressions. So this is an example. We know that what is input buffering. We might have studied about input buffering. So this is a buffer in which your that is the input stream of characters are going to be kept inside, and we are going to identify the token. So this is the sentinel at the end of each buffer. So there is a sentinel at the end of each buffer. This buffer is going to have 2 pointers. One is lexeme beginning and another one is forward. So lexeme beginning is going to be at one position, and the forward pointer will, that is start of the token, will identify the start of the token, and the forward pointer will move one step ahead. So, both the entire buffer is going to be divided into 2 halves. So every half end is being identified with EOF. EOF here it is called as sentinels. Sentinel identify the end of the buffer. And here the lexeme beginning is pointing to this star, and the forward pointer is moved to this 2, right? So whenever it encounters an end of file, so sometimes it may be identifying the end of the input also. So this EOF is going to be the sentinel for identifying the end of the input, right? Okay. So now, this is the program for buffering for identifying the tokens in strings and languages. So far alphabets we have seen, strings we have seen. From the strings how the languages are coped up, that we have seen. From that language we are going to identify the tokens. So the strings are kept in buffer. That can be identified as what? From that we can identify the tokens with the help of this program. Say switch forward pointer. Always the forward pointer move one step ahead. So that is why forward plus plus is given. Since it is a pointer, the forward pointer moves one step ahead. So plus plus star forward plus plus. Since it is a pointer star, it has been mentioned. Plus plus is one step ahead it moves. So you are going to switch on with some of the cases. If forward pointer is going to scan the input and it is not end of file, simply it will forward one step ahead it will go, right? if it is an end of file, while on scanning it finds an end of file, this sentinel, if it is finding this end of file, so it will go to that particular case called as end of file. So what this end of file case is going to do, see, it is going to check if the forward pointer is at the end of the first buffer. Whether this forward pointer is here in this end of the first buffer, it is going to check. If it is here in the end of the first buffer, then it reloads the entire second buffer, and the forward pointer will move one step ahead and start from here. If the forward, so don't consider this, see, if the forward pointer is here, what will happen, it reload the second part of the buffer, and then the forward pointer will move one step ahead, which means that a new input it is going to start reading. Okay, so forward pointer will move on to the beginning of the second buffer, that is what. So if the forward pointer is at the end of the first buffer, this is the first buffer, first half of the buffer, then it moves, it reloads the second half of the buffer, and it moves to the forward pointer will move to the beginning of the buffer, right? Let me consider lexeme is here, lexeme is here, okay? And if it is not at the end of the first buffer, what does it mean? Either it may be in between this thing or in between this thing, or it may be at the end of the second buffer. Anywhere it would be, right? So now we are going to check the second option. If the forward pointer is at the end of the second buffer, now the forward pointer is at the end of the second buffer, what we have to do? We have to reload the first part of the buffer, and the forward pointer will wrap around to the first position of the first buffer, right? So reload the first buffer. If the forward pointer is at the end of the second buffer, reload the first buffer. Yeah, it reloads the first buffer for getting new inputs, and forward pointer will move to the beginning of the first buffer. So from here the forward pointer will move to the beginning of the first buffer. If these two things are not the case, then which means that, so the another end of file is here, right? So either the end of file must be in the first half end or in the second half end of the buffer. If these two are not possible, which means that it may identify, the other EOF may identify the end of the input, right, in between these two. Either it may be in first half or in the second half, in between the forward pointer would be. So else means it is going for EOF within a buffer marks the end of input. So this EOF is going to mark the end of input. So when it comes to identify that, so it is at the end of the input, then it has to terminate the lexical analysis phase because it has read all the input characters. So that is why after finding the EOF, that is if the EOF, the forward pointer is at this EOF, which means at the end of the input, then it terminates the lexical analysis and breaks. So this is the strings and languages. So in strings and languages, first one is alphabet, and then we formed with strings, we have gone with strings, and then we have gone with languages. Now we have seen how the input has been that is traced out using the input buffers with the code, right? Okay, so continuing with strings and languages, longest match rule is there in string, that is languages. So when the lexical analyzer reads the source code, how the lexical analyzer reads the source code? From the left to right, it scans the input one after the other after getting a get next token command from the syntax analyzer phase, isn't it or not? So when the lexical analyzer reads the source code, it scans the code letter by letter, that is from left to right, one after the other, it reads the character. And when it encounters a white space, when it comes to when it happens to see a white space or an operator symbol or special symbol, it is telling you that it forms a that is, it has identified a string. So usually how will you write a statement, say for example, how are you, how space r space you. So now the scanner, that is the lexical analyzer phase, is going to start reading from H. It reads H letter, and letter by letter it is going to read. H it reads, O it reads, W it reads. When on reaching with the blank space, then it finds that how is an identifier. How is an identifier. So this is what happened in the lexical analyzer phase, right? So example, they have given an example here, int value. So the longest match rule states that lexeme scanned should be determined based on the longest match among all the tokens available. So this is what, so it has to check with the longest token also, available longest tokens also, then it has to say the longest match rule. Also this lexical analyzer phase uses an rule priority also. So in rule priority, keyword is always given a higher importance than that of the identifier. See here, the lexical analyzer also follows a rule priority where a reserved word, example a keyword of a language, is given priority over user input, right? Or identifier means the user defined variables. Okay, so keyword is given most important than that of, that is higher priority than that of the user input. So this the string of languages continuation, so in which we are going to see some of the properties of string related terms. We may say that it is string related terms. So prefix, suffix, substring, proper prefix, subsequence. So these are the 5 string related terms that we are going to see under strings and languages. Prefix, say for example, we are considering banana as an example of it. Banana is the example of it. And when we want to find a prefix of this string, say S is the banana. So string S is nothing but what? Banana. And I am going to find the prefix of this string S. Okay. So which is nothing but any string obtained by removing 0 or more symbols from the end of S. So either I may remove, I don't remove any of the character. Banana itself can be called as a prefix. Or even if I remove, A can be removed, N can be removed, that is NA can be removed, ANA can be removed. Then after removing, what will be the resultant string? Resultant string is BAN. So that can be an prefix also. So we are going to apply the prefix related, that is we are going to have the prefix of a string S as any string obtained by removing 0 or more symbols from the end of the string. So from the end of the string, either you may remove or you may not remove. Even if you may not remove, banana is the entire answer, that is the prefix answer. Even if you remove, any numbers can be removed, any number of characters can be removed, right? A can be removed, NA can be removed, ANA can be removed. Then it will be like ban as a prefix of banana. Okay, prefixes of banana. Okay, what is a suffix then? What is a suffix? So the same example, string S, banana has been considered. The suffix of string S is any string obtained by removing 0 or more symbols from the beginning of S. This is what the difference. Prefix means what? From the end of the S. Suffix means what? From the beginning of the S. So let me consider the same example, banana here. So I am going to remove 0 symbols from banana, then banana itself is the answer as suffix. Even if I remove, B can be removed, BA can be removed. So if I remove BA from the BA characters from the string, na, the resultant is the suffix. NA is the suffix for banana. Okay. Substring. Substring is nothing but what is obtained by deleting any prefix or any suffix from S. So which means that let me consider the same example, banana. B can be removed, A can be removed. AN can be a substring. So here they are going for epsilon or substring of banana. So when you apply epsilon for finding the substring, then nothing can be removed. So banana itself is the answer. Even if I apply the prefix and suffix removing here, say for example B is being removed for suffix, A is being removed for prefix, then AN is the answer for substring. Then we are going for proper prefixes, suffixes and substring of a string S are those prefixes, suffixes and substrings respectively of S that are not epsilon or not equal to S itself. So whatever you are generating, it should not be epsilon, that is the proper prefixes, suffixes and substrings should not generate the same string. Say if I am giving the example as banana, banana itself should not come as a answer. So that then it will be called as what? Proper prefixes, suffixes and substrings. And then coming for a subsequence of string S, it's formed by deleting 0 or more, not necessarily consecutive positions. So far the prefix and suffix is meant for consecutive positions. Say for example, if I am removing A from here, and if I try to remove N, then I have to remove it like NA for prefix. Similarly for suffix, if I remove B, that's fine. If I go with another letter, say BA, consecutively it has to be removed. BA suffix has to be removed. But in subsequence, it is not necessary that consecutive positions are to be eliminated. Say for example, BAN is a subsequence of banana. Say why? B is there, A is there, N I removed, okay, and AN I have, and A. It is not necessarily what? Consecutive in nature. So this is called a subsequence. These are the 5 string related terms. One is prefix, suffix, substring, proper prefixes, suffixes, substrings, and then the subsequence of S. Of any string you can have this, right? So the second, so the first one, according to this, we have seen the formal notations of strings and languages. Under strings and languages, so far we have seen about. The next one, what we are going to see is operations on languages. So far we have seen in strings and languages is all about alphabet. What is a binary alphabet? What is a string? And what is a language? Then the input buffering concept of the strings and languages with the code we have seen. And then the strings and languages with the longest match rule we have seen, and then terms of short, that is string related terms we have seen. Now coming to the next topic of the formal notations, that is the operations on languages. What are all the operations that can be performed on languages, that we are going to see now, right? Okay, so union of L and M. L is a language, M is a language. As you all know, L is a language means it has its own finite set of strings and finite set of alphabets. Similarly, M will have its own finite set of strings and own finite set of alphabets. Okay, fine. So union of L and M. L language and M language is going to be combined. So it is going to form a string where S is in L. This S, the string whatever you are going to have, may be in the language L or maybe in the language M. Say for example, L is the language of alphabets from English alphabets from A to Z, and M is a language of digit alphabets from 0 to 9. Now I am giving you a string called as 1, 2, 3. This 1, 2, 3 is in L? No, because it is in English alphabet. Whether this 1, 2, 3 is in this digit alphabet? Yes, it is, because it is a combination of 1, 2, 3 is the digit that has been mentioned by this language. Then followed by the concatenation of L and M. That is L followed by M. That is the language L followed by the language M, ST. Where S is in L language and T is in M language. Okay. Say for example, I am having A1. I am having a identifier called as A1, where A belongs to the language L and M belongs to, that is 1 belongs to the language M. Since I told you that L is an English language, consider for an example, consider L is the language with an alphabet A to Z, and M is the language with the alphabets from 0 to 9 digit alphabets. Okay. So if I am having an example like A1 here, A belongs to L and 1 belongs to M. So that is A belongs to S. A is a string called as S, which belongs to L, and followed by, immediately followed by 1. 1 is T here. T is in digit alphabet M. Clear? Any doubt? So fine. Then we are going with clean closure of L. As we all know that what is the star implies. The star means clean closure. Any language can have its clean closure property. What is a clean closure property? It may appear or it may not appear, which means that 0 or more times, right? So that is why here the I value starts from 0. So L language power 0. L language power 0. So L language power 0 will be what? 1. Anything to the power 0 is 1 over here, right? So 1, it is going to be an empty string, that's it. And even if it takes set of characters, it may be from 1 to infinity it can have. That is what the language can have, the clean closure property like this, from 0 to even it may take 0, or even if it has, it will from 1 to infinity it will take. Okay. And positive closure, we all know that 1 to that is, it appears once, and then you can have any number of appears, one or more times. You say it as what? Positive closure is one or more times. That is why your I value here starts with 1. It is not 0, instead it starts with 1. At least one characters must be there, that is one alphabet must be there, one language must be there, and you can have what? Infinity. You can have any number of languages also. So these are the definitions of operations on languages. So far we have seen about the operations of languages. What are the operations that can be performed on languages is nothing but union, concatenation, clean closure of L, and positive closure of L. Okay. So what would be the other operations? Say for example, they have considered the L alphabet, that is L language, with a set of letters like capital A to capital Z, small a to small z, and D is the set of digits from 0 to 9. As so far, what did I say? No, that one they are considering. Okay. L union D, that is language L union D. They are going to combine these two, which means that 26 letters of alphabet, uppercase alphabets 26, lowercase alphabets 26, totally how many? 52 alphabets it will be taking, and remaining 10 digits it's going to take. So which means that 52 plus 10 is 62 strings it is going to have. So if I combine these two languages with the alphabets of this one, which means that it is going to have 62 strings of length 1. Okay, if I consider the length 1 alone, say for example A individually, B individually, C individually, like that, uppercase all individual 1 characters from A to Z, and lowercase all characters from small a to small z, and the digit from 0 to 9 all together is going to be what? 62 strings of 1 character, 1 length. Okay. And then LD, here it is union operation. Here they are going to have what? Concatenation operation. What is concatenation operation? Here they have defined 520 strings they have defined for length 2, which means that A1, A2, A3, A4, A5, A6, A7, like that. For A alone, A9 is going to be there, right? So 10 characters. Similarly for B1, B2, BZ, it is going to be another 10. So similarly, for 26 characters, 260 characters you'll get, right? For of 2 length, right? After letter, it is going to have a digit. From A1 to, from A0 to A9, 10 characters, B0 to B9, 20 characters. Similarly, till Z0 to Z9, 260 characters you are going to get. That is 260 strings you are going to get for uppercase. For lowercase, small a1, small a0, small a1, so on up to small a9, like this 10 characters for a, small a, and small b0 to small b9, again 10. Similarly, for this set you will be getting 260 characters, 260 strings. The capital concatenated 260 strings plus the lowercase letters of 260 strings together forms what? 520 strings of length 2. So this is what the example they have defined here. And L to the power 4. L to the power 4 means what? The set of all 4 letter strings. So in a particular language, that is this language, from A to Z, capital Z and small a to small z, you are going to have all 4 letter strings. When, what, these are the 4 letter strings. And L to the power of star is a set of all string of letters including epsilon. So L to the power star means what? Clean closure. Clean closure is 0 or more times. So this may be the set of string with empty string also it will consider, since it is a clean closure, it starts with 0, right? And the remaining all set of strings of letters it is going to consider. What is this then? L followed by letter union digit, that also 0 to more times. At least, that is, this is an identifier actually. So it must start with a letter followed by letter or a digit, that to 0 or more times. This set may appear 0 times or it may not appear at all, but there must be at least one letter. and followed by what? After following that particular letter, you can have any number of combinations of letters or digit. Even if you don't have that combinations, it is not a problem according to this rule. Okay. And the next one is d power plus is the set of all strings of one or more digit. D is digit from 0 to 9 as per the rule. So plus means what? 0 or more times. So it is the set of all strings of one or more digits. So this is what the examples that we have seen about the operations and its notations for the operations on languages. Okay. And the next topic is regular expressions. So regular expressions can be used to specify the structure of the tokens used in the programming language. You all know that what is a regular expression. A or B the whole power star, A B B is a regular expression. A power star is a regular expression. A power plus is a regular expression. You know that, right? So it is specifying the structure of tokens, how it is going to appear in the programming language. So it defines the pattern for the tokens. Yes, of course, the regular expressions are going to define the set of rules for the tokens. When comparing this pattern against a string, it will be either be true or false. It may be true or false. Okay. So what is the regular expression is going to tell you? Whether this it is going to compare with the set of rules. If it matches with the set of rules, it will accept the string like saying yes, it is true, right? If it is not according to the set of rules or the patterns, then it says that it is false. So the set of strings described by the regular expression is called as regular set, and the language will be described as what? Regular language. So whatever the regular expression is going to describe, whatever strings that the regular expression is going to be described, that set of strings are going to be called as regular set, and that particular language will be called as regular languages. Okay. So now coming to the next point of regular expressions, there are two rules that forms the basis of regular expression. One is epsilon as a regular expression. So you are going to have in an epsilon concept. So epsilon is also called as a regular expression, where language which can have what? Epsilon. So language of epsilon is, that is language of regular expression. This epsilon is regular expression. Language of regular expression epsilon, because they have given here as what? Epsilon is a regular expression. Language of regular expression epsilon is a set with the alphabet what? Epsilon. So that is the language whose sole member is the empty string alone. So epsilon is the only string that you are having in that particular language. Another language they are giving like L of A. So A is a symbol in set of alphabets. This summation symbol is nothing but what? Set of alphabets. Where A is the only symbol in that set of alphabets, then A is a regular expression. Yes, of course, A is a regular expression. So how can you identify? L of this regular expression has only one character, say A in the set of alphabets. That is called as A in the set of alphabets. So it is going to have only one string, which is nothing but what? A, whose length is going to be 1 with A in its 1 position. So we use italics for symbols and bold face for their corresponding regular. So regular expressions are identified as bold letter, and italic A is identified as symbols. Okay. So this is about what? Regular expressions. The continuation of this regular expression, inductions are used. So there are 4 parts to the induction, whereby larger regular expressions are built from smaller ones. So the R is one regular expression, and small letter S is another regular expression they are taking. Okay. So capital L of R, that is the language that that denotes this regular expression R, and another the same language that may denotes what? Yes. Okay. So the induction may be defined as follows: R or S. Small letter R, this is a regular expression. Small letter S, this is also another regular expression, and in between R symbol. Either this or this we used to say, which means that it is a regular expression denoting the language of L of R or L of S, which means that L of R union L of S. This is what we have seen in the operations also, operations and languages also. Okay. And then R into S is a regular expression denoting the language L of R, L of S, which means that it is a concatenation operation, and this is a clean closure This is a regular expression denoting L of R the whole to the power star, and R is a regular expression denoting L of R. This last rule says that we can add additional pairs of parentheses around the expressions without changing the language they denote. So we can add the additional pair of parentheses also. So these are the examples of inductions that given under what? Regular expressions. So the regular expression always have unnecessary pairs of parentheses, because much of parentheses can be allowed in induction also, right? So it can have unnecessary pairs of parentheses. So we may drop certain pairs of parentheses if we adopt the convention that unary operator has the highest precedence and is left associative. So these are the priorities they have given. One is highest precedence is nothing but given to what? Star, that is a clean closure, which is a unary operator which can be applied on only one operand. So it is a unary operator which has the highest precedent and it is left associative. Concatenation has the second highest precedence and it is left associative. OR symbol has the lowest precedence and is left associative. Say for example, you can have a regular expression according to this induction method. We can have describe an expression like this, that is A or B, either A or B star C can be written as A or B star C. So both expressions denote the set of strings that are either a single A or 0 or more B, 0 or more B's followed by one C. So A is a single A, you may have it or you may not have it, and B is 0 or more times, and C is you are having only one C at the end. Okay. So this is the third topic under regular expression. So far in regular expression we have seen about the introduction part. Then we have seen about the rules of regular expressions. Then we have gone with induction, and then we have gone with the precedence, followed by an example we are going to see. So A or B denotes the language. So this is the regular expression they have given, A or B, which means that this regular expression has only two alphabets. One is A, the other one is B. So that language denotes the language with the alphabets A and B. Okay. So let me consider this example, A or B followed by A or B denotes. What would be the answer for this? From A it may either take A or it may either take B, right? This A it may take, or this may A it may take, right? So that is what, not this is not the star operations, sorry. So from here this A, this may take this A, right? So A and then A followed by B it can take. Similarly, BA, this B it can take, and BA, and then it may be BB. Okay, so BA or BB. So it is of length of over alphabet set over the alphabet set of alphabets. Another regular expression for the same language is AA, AB, BA, BB. From this you have derived it. So A star is a clean closure where you start with what? Epsilon. That is, since it is clean closure, it may start with 0 followed by a single letter, many letters. That is single A, double A, multiple A, any number of A's it would be. A or B, the whole power star means what? It may take either A or B, or that is epsilon it may generate, or either A it may take, okay, or B it may take, okay, or again and again it may take A alone, that is AA. Any number of A's can be taken, triple A, 4 A's, 5 A's, like that it goes on. If it takes B, BB, triple B, 4 B's, like that. Even the combinations of A and B, yeah, it's fine only. So it will take. That will also be called as the regular expression. Another regular expression for the same language is A to the power star, B to the power star, whole to the power star can be given. So like this also, the same way this regular expression can be rewritten. So this another one is A or A power star B, which means that one A it is going to have, right? This A it is going to have denotes the language A or B or AB, or this AB, AAB triple A, B, like that it goes on. Okay. So these are some of the examples with the alphabets A and B alone. You can have any number of alphabets in a particular language. So the regular expression law, algebraic law for regular expressions we are going to have. So first one is commutative property. R is a regular expression, S is a regular expression. Where how will you apply the commutative property over R symbol? R or S is equal to S or R. And similarly associative property over R symbol you are going to provide, that is R or S or T is equal to what? R or S or T. Similarly concatenation is associative over here. So R into ST is equal to RS into T. That is concatenation. R concatenated with ST which is equal to RS concatenated with T. So concatenation distributes over R symbol. So using the R symbol, the distribution how it is going to happen, R within bracket S or T can be written as RS or RT. Similarly S or T over, that is altogether over R regular expression can be rewritten as SR or TR. So any regular expression that has been concatenated with epsilon, that is epsilon concatenated with any regular expression, the resultant would be the same regular expression. That is what. So this has been given as what? Identity. So we used to have that identity property, no? That is what? Epsilon with R similarly equal to R regular expression with epsilon, which is equal to the regular expression itself. And another one is epsilon is guaranteed in a closure R to the power star, which is equal to R epsilon or whole to the power star, you can write. R double star is nothing but what? Clean closure. This is also 0 or more times, this is also 0. Why to say 2 times of 0 or more times? It is enough to have only 1 to the power star, which is an idempotent. So R to the power star can be written, which is an idempotent. These are the algebraic laws for regular expressions. Now coming to the regular definitions. So regular definition is a sequence of definitions of the form. So here set of alphabet is an alphabet of basic symbols. Then regular definitions is a sequence of definitions of the form D1 produces R1. So say for example we are going to have an example like identifier. Identifier always how we will write? It must start with a letter followed by letter or digit, that to any number of times. That is L open parenthesis L union D whole to the power star we have written. So that is called as what? Identifier, right? So D1, that is a definition, regular definition of a particular. So D1, D2, many number of definitions can be given like this for a number of regular expressions. So where DI is a new symbol. So D1, D2, so on up to DN you can have. That is a new symbol, not in some set of alphabets and not the same as any other of the Ds. So if once I have defined with D1, if I am going to go with another definition, then I have to give it the number as what? D2. I have to have different name of it, right? So similarly definition 3 if I go, I have to have different name for it. Similarly every time when you go with new definitions, that must be a different name which should not be a duplication of the earlier definitions. So each regular expression is a regular expression over the alphabet epsilon union, sorry not epsilon, it is a summation symbol, set of alphabets union all the definitions whatever you have described that you are going to have. Say the regular definitions, here they have given, see here, letter is nothing but what? All the letters. Digit, this is one definition. Letter are nothing but what? It may take A, B or so on up to Z, small letter A to Z. Digit is from 0 to 9. So this is another definition. And ID is an identifier wherein it starts with a letter followed by letter or digit whole to the power star. Say for example any variable declaration if we have, always the variables must start with a letter. Say sample if we are having, yes, sample 1 2 3 if we are having. Say for example we are having sample 1 2 3 as an example. Sample is a letter. It starts with S. So one letter it must start yes, followed by AMPLE is a letter, and or it must be combinations of SA 1 2 3 like that also it may come. AMPLE 1 2 3 all together we get it as what? Sample 1 2 3. So for unsigned numbers also the definitions can be given. So first one is digit from 0 to 9. Say for example, I am considering the number 5. So it comes under what? Digit. It comes under what? Digit. Now I am going to consider digits. Say for example 5280 is digit. So it must start with the digit first. Yes, it must start with the digit 5. 280 is what? It's up to the choice. 0 or more number of times. 2 may come, may not come. 8 may come, may not come. 0 may come, may not come. So that is the combination why they have given it as digit star. But it must have at least one digit for digits. Okay. And then we'll go with optional fractions. So optional fraction is this one, right? So after this dot, you'll have a digits. Digits means what? It must start with a digit followed by any number of digits. So it must start with a, after dot, it must start with a digit followed by any number of digits. Yeah, fine. I put it. Or else you can have epsilon. Optional fraction itself may not be available for a number. So you may put it as what? Epsilon. And for the number, let me explain optional exponent with the number here. So we'll have a number. Say for example, I am having this E4, this number, okay. So digits, it is taking with digits. So it is going for digit here. It must start with a digit. Of course, it starts with 6 and followed by any number of digits. So it doesn't have any following numbers of this digit, right? Only 6 it has taken. No problem, because the star has been given. It is 0 or more times. So 0 it has taken. So no numbers after 6. And then optional fraction it is going. Whenever it goes for optional fraction, it is giving dot symbol here. So dot they are giving here, yeah, fine, and followed by digits again. So digits, when I go for, it must start with the digit, say 3, and followed by number of digits. Number of digits means what? 36 is the number of digits. 2 digits they have taken. And after this optional fraction, you are going to have what? Optional exponent. So when I go with the optional exponent, it must start with E. Yeah, it is starting with E. After E, you may have these 3 combinations like a plus. You can have plus, minus or epsilon. Or any of the 3 you can have. So in this example, they have taken nothing. So they have taken what? Epsilon. Even you can have plus or minus here. Then followed by digits. What is the digits? Digits are nothing but digit followed by digit to the power star. So they are having for this digit they have taken 4. Even after that 4 you can have any number of digits, even if you don't have, no problem. Then that is what called as the optional exponent. So even some cases the E part itself will not be available. That is also possible for a number. So a number can be a single digit or combination of digits. Optional fraction may available or may not available. Then also it is called as a number. Optional exponent may available, may not available after optional fraction. That may be also be an epsilon, right? So that is 0 state for that. So the last topic of this formal notations under specification of tokens is extensions of regular expression. So one is one or more instances. One or more instances means you regularly put it as what? R to the power plus. R to the power plus, which means that it must start with R followed by 0 or more times of R. That can be rewritten like this. That is R to the power R to the power star, or R to the power star R. So in both the cases at least one R you'll get, right? So this is relate the clean closure and the positive closure. This is clean closure here. You can avail positive closure for one or more instances, which you will denote it as what? R to the power plus. So if this is the regular expression with which you are denoting with plus in, which means that the language itself is in one or more instances. That is this plus operator is a postfix operator. After the regular expression you are writing, so it is a postfix operator. And now coming to the 0 or 1 instance. So we have seen about 0 or more instance with clean closure, right? 0 or 1 instance. For 0 or 1 instance, you will be having this question mark symbol. Regular expression followed by a question mark means, which means that it may appear, may not appear. Even if appears, it will appear for one time. One instance it will appear. So that is what 0 or more instances. And the character classes. So the shorthand notations for writing character classes would be, Say for example, ABC is the shorthand for if we within a square parenthesis, if we put it like ABC, the shorthand for A or B or C. So instead of writing the letters like small a, comma, small b, small c, so on up to like this, you can have it like this. Say, see here, A or B or C or D, so on up to Z. Instead of writing like this, the shorthand can be written as like small a to small z. This is a character class. So this set of class alphabets in that particular class is called as the character class. And the extension of regular expression. So the shorthands we are going to use. See, for example, in this slide we have seen the letters like A to Z, small a to z. So how can we write the shorthands for this? Letter, this arrow mark, within square parenthesis, capital A to capital Z, small a to small z. Similarly, digit, within square parenthesis, 0-9. We can put it like this. So that is what been mentioned here. So letter A to Z, small a to z, digit 0 to 9, ID is letter followed by letter or digit, the whole to the power star. So the regular definition, everything is a definition, right? Digit is 0 to 9, digits are digit plus, and numbers are like this, you can write. So this is the extensions of the regular expressions, and the regular definitions can be written like this. So that's it all about your specification of tokens. So under specification of, a quick recap we'll see, and we'll end up with the session. So specification of tokens, we have seen about lexeme, pattern and token. And under the specification of tokens, we have seen about strings and languages, under which we have seen about alphabet, strings and languages, and then the input buffer and longest match rule, and then the terms, that is prefix, suffix, substring, proper prefix, suffix, substrings, and then the subsequence we have seen, and then the operations. Second topic was operations on languages, under which we have seen about union, concatenation, clean closure and positive closure, and examples of that we have seen. And the third topic is regular expressions. So under regular expressions, we have seen about the basis rules for the regular expression, induction method, and then the priority, precedence we have seen, and followed by the example for writing the closures, positive or clean closure, everything we have seen about. And then algebraic laws for regular expression we have continued with. And finally, in the fourth topic, we have seen about the regular definitions. Every definitions can be, that is every regular expression can be defined as regular definitions. Example of it we have seen. Then finally, the extensions of regular expression, 1 or more instances, 0 or more instances, character classes, and along with that example we have seen. So with this topic, the specification of tokens gets over in your first unit of compiler design. Thank you all. Thank you.